Hello all, welcome to MG Engineers Academy. In last session, we had discussed about the property division by T, and in today's session, we are going to discuss the problems based on that property. So, we'll start. Laplace Transform property division by T, and today we are going to discuss examples based on it. So, before proceeding ahead, what is the property? Laplace of f of t by t is equal to integration s to infinity f bar of s ds, right? This was the property which we discussed in last lecture. Now, example first, a raised to minus 80 minus a raised to minus bt upon 1t, right? So, what we have to do? We have to find Laplace of e raised to minus 80 minus e raised to minus bt upon t upon t. Now, what we are going to do? So, what I can do? I am going to find first Laplace of e raised to minus 80 e raised to minus bt, right? So, what is that? So, we have what formula we are going to use in this case. So Laplace of e raised to 80 is equal to 1 upon s minus a. If it is minus 80, then we are going to change it to 1 upon s plus a, right? So we are going to apply this Laplace formula, and what we will get? We will get Laplace of e raised to minus 80 minus Laplace of e raised to minus bt. Then what can I write? 1 upon s plus a minus 1 upon s plus b, right? So, so we have received the value of Laplace e raised to minus 80 Laplace e raised to minus 80 minus e raised to bt minus bt. So this was the value for it. But what we have to do? We have to find Laplace for e raised to minus 80 minus e raised to bt upon t, right? What we are going to do? What is the Laplace for f of t means division by t? I will mention by property of division. What is the property of division? Laplace of f of t upon t is equal to integration s to infinity f bar of s ds. Now, what is the bar of s? We have find this value. This is the f bar of s. So, what I can write s to infinity, right? 1 upon s plus a minus 1 upon s plus b ds. So I need to find the integration for this term, right? Okay, we have to find integration. Now, in 11 and 12, what we learned? We have learned that integration of 1 upon x, right? 1 upon x dx is equal to log of x. This is the formula which we have learned in 11th and 12th standard. So I'm going to apply the same formula here. So what can I get? Eh, Bracket, I will write integration of 1 upon s a will be log of s plus a minus log of integration of 1 upon s plus b will be log of s plus, right, and limit is s to infinity. Now again in 11th and 12th standard we have learned one more formula. Our formula is log a minus log b is equal to log a by b. This formula we have learned in 11th and 12th. So I'm going to apply the same formula here. So what can I get? I can write log of a. This term will be a and this term will be b. Log s plus a with log s plus a upon s plus b limit s to infinity. So I'm going to put the value of infinity the place of s. So this is the upper limit and s is the lower limit. The same way I'm going to put the lower limit s at the place of s. So what can I get? Log of s place is now infinity because we are going to put upper limit infinity plus infinity upon infinity plus p plus b minus log of s plus a upon s plus b. That's it. Now we are going to simplify this further, what we can write log of infinity plus any constant will be infinity upon infinity minus log of s plus a upon s plus b, right? So after further simplifying it, I can write log of 1 minus log of s plus a upon s plus b, right? Now, what is the value of log 1? What is the value of log 1? Log 1 is 0 minus log of s plus a upon s plus b, right? So, minus log of s plus a upon s plus b. Okay, now you can keep this answer as it is, or you can apply one more formula which we have learned in 11th and 12th, that whenever there is minus log a upon b, okay, means if log is minus, then if you want to make it plus log, then you can make it plus by just changing the term a upon b to b upon a. That's it. So if I want to make plus log, then log s plus b upon s plus a. That's it. This is the answer for the equation or Laplace of e raised to minus at minus e raised to minus bt upon t. Right? Now we are going to discuss second example. Cos of at minus cos of bd upon t. Right? What we need to do? We have to find the Laplace form cos of at minus cos of bt upon t. First, we are going to find the Laplace for this term, right? Cos of at minus cos of t. Now we have learned Laplace of cos at will be s of s square plus s square. So I'm going to apply the same logic here. What can I get here? Okay, I will further simplify it. Laplace cos at plus Laplace of cos b. So I can write s upon s square plus s square minus s upon s square plus b square, right? Now, by applying division rule, so what can I mention? Now I have got the value for this term cos at minus cos bt, but we have to find the Laplace for this entire term, right? So what can I write? I will write Laplace of cos of at minus cos of bt upon t is equal to, what is the property of division rule? Integration. s to infinity f bar of s into ds. Now, what is the f bar? This is the f bar. So I will write ds to infinity s upon s square plus a square minus s upon s square plus b square, right? Into ds. Now, if we move ahead, what we can do now? Okay, in 11 and 12, we have learned one more formula. Okay, let me tell you that formula as well. Okay, integration f dash of x upon f of x dx will be log of f of x. So let me explain what exactly this means, what exactly the rule is. Okay, log of x, right? Means in integration, if at the upper side we have derivative of function f of x, then we can directly write log of f of x. So what will be the example? Let me tell you example. Okay, let me take the example this one only. So what we can do here? Suppose integration of s upon s square is. So this is the apex term. What is the apex term? S square plus a square. If we derivate this means f dash of x. If we derivate this term s square plus a square with respect to ds, then what I can get after derivating it, I will get 2s, right? But here we already have term s. Only 2 is missing. So in order to balance, what can I do? I can write 1 by 2 integration 2s upon s square plus a square. So I have balanced 2 so that I can get this formula in our scope. So now if you see fx is s square plus a square and f dash of x. If I derivate this s square plus a square, then I will get 2s. So in this case, I'm going to write directly log of fx x s s square plus a square s square plus a square. So same logic will be here. Log of. Wait, I'm not going directly. I will go step by step so you will able to understand. So I'm going to balance 2 here because if we see s square plus a square, if we balance it by 2, we will get the formula in our scope. Same way here also I'm going to balance it by 2, right? So what can I write? Integration s to infinity 2 by 2 into s upon s square plus a square minus 2 by 2 s upon s square plus b square. Right? Yes. So I have balanced the inside value of s upon s square plus a square by adding and sorry, by multiplying and dividing 2. So I have balance. So what can I get? So I will write s to infinity 1 by 2 into 2s upon s square plus a square minus 1 by 2 into 2s upon s square plus b square, right? Into ds. From this 1 by 2, I will take it out. It's a common. So s to infinity 2s upon s square plus s square minus 2s upon s square plus b square into ds. So now it is in our desired form. So I will write it directly upon. I will write log s square plus a square minus log of s square plus b square and limit s to infinity. Now I'm going to put infinity as upper limit wherever s is present, and I am going to put lower limit s wherever s is present. So what can I get? 1 by 2 log of infinity plus a square. Infinity plus constant will be the constant, sorry, will be the infinity only. Okay. So log infinity minus, I'm going to put yes log of s square plus a square. This term will be as it is minus log of infinity minus log of s square plus b square. So 1 by 2, this term will be 0 log of s square plus s square minus this term will be 0 log of s square plus b square. Now what can I write here? Here I can write 1 by 2 minus log of s square plus a square minus log of this minus become plus, right? Log of s square plus square. So what can I write? 1 by 2 log of s square plus b square minus log of s square plus s, right? So we have formula log a minus log b is equal to log a by b. 1 by 2 log s square plus b square s square plus a square. And this is the answer. Now we are moving to example number 3. 1 minus cos t t. We have to find Laplace for 1 cos t t. Right? First, we are going to find the Laplace for 1 minus cos of t. So we learn value for Laplace cos a t is equal to s upon s square plus a square, right? So we are going to find the value for this term. Laplace of 1 is 1 upon s minus s upon s square plus a is 1, 1 square will be 1. So I got the value for Laplace 1 minus cos of, right? Now what we have to find? We have to find Laplace of 1 minus cos of t upon t. So I will directly mention by applying division rule, right? What is the division rule? Laplace of f of t upon t is equal to integration s to infinity f bar of s to ts. So what is f bar of s? We have got this f bar of s term is f bar of s. So what can I write here? Integration s to infinity f bar of s 1 upon s minus 1 upon s square plus 1 into ds, right? So equals to, now in last example we learned integration of 1 upon x will be log of x, and integration of s upon square plus 1 f dash of x on f of x is log of x, right? We can, we are using this two formula in this equation now. So in this equation, okay, let me, before proceeding ahead, let me explain you one term here. This one. Okay. What is the term? S square, yes, upon square plus 1, right? Now, if we are going to use this formula, then this formula states that f dash of x upon f of x is equal to, we will write directly log f of x. Means f of x term is, suppose example, s square plus 1. Then the bottom s square plus 1 and f dash of x, means if we derivate or differentiate this f of x with respect to x, then what we can get, if we differentiate, this will be 2s. Means whenever we have this kind of integration in the place and time, we can write directly log of fx. The same situation is here. We have s upon s square plus 1, right? Term is there. Only missing part is 2. So we are going to balance the term 2. So I'm going to write integration s to infinity. I'm going to write 2. So what can I do? I can do multiply this term 1 by s on multiply and divide this entire bracket 2 by 2 means I am going to multiply by 2 and I'm going to divide it by 2 because I'm balancing this term. So minus 2 into s on 2 into s square plus 1, right? For further simplification, what can I do? I can take 2 common, 1 by s to infinity upon 2 upon s on s minus 2s upon s square plus 1 to ds. Now we are going to take integration, right? What can I write? 2 log of s. Integration of 1 upon s is log s minus 2s upon s square plus 1. We can directly write it as log of s square plus 1. Limit s to infinity. Now I am going to put the limit in this bracket, but before going to this, I can show you one more formula. A log of b. If we have the term like this, a log of b, we can simply write log of b raised to a. Same logic I am going to apply here for this 2 log s. So I can write log of s square minus log of s square plus 1 s to infinity. Now I'm going now after this I can write 1 by 2. I'm going to apply this formula log a minus log b will be log a by b, right? Log s square upon square plus s to infinity 1 by 2. Now I'm going to put this upper limit and lower limit now. Log of infinity square upon infinity square plus 1 minus to put this now will be the as it is term. So 1 upon 2 log of infinity upon infinity will be 1. It would directly write to 1 value here 1 minus log of the square upon the square plus, right, here 1 by 2 log 1 0 minus log of the square upon the square plus 1, 1 by 2 minus log of minus log of the square upon the square plus 1. So we also learn log minus log a by b, can write it as log b by, so that this minus will be converted into plus by just changing the term b by a. So I'm going to change it by 1 by 2 log of s square plus 1 upon s square.